Alright, this example says, why is mass irrelevant in where you place a satellite in orbit? So it doesn't matter if it's a big communication satellite, a very, very small satellite, something you're launching in. Mass actually has nothing to do with any of those, and let's explain why. So we said that when you have an object that moves in circular motion, it has to have a centripetal force. Now, the centripetal force that is provided to a satellite is the gravitational force that exists between the satellite and the Earth. So, because of that, we know we have a centripetal force. Well, the formula that we learned for centripetal force is mvt squared over r. Okay? With this mass being the orbiting mass, or let's say the satellite. We also have the gravitational force formula. We know that the gravitational force is what actually supplies the centripetal force. We know that the gravitational force can be calculated using Newton's law of universal gravitation, which basically says you have a universal gravitational constant. You have mass 1, which is the mass of the Earth. You have mass 2, which represents the satellite. And you have r, which is once again the distance between them. Since the centripetal force is the gravitational force, you can say Fc equals Fg, or if we were going to plug in our things, you have mvt squared over r equals m1 m2 over r squared. Left the g term off. Okay, so now realize that this is the mass of the satellite, and m2 was once again the mass of the satellite. So these two things are actually the same thing. If you have the same variable on both sides of the equations, you can actually eliminate it. You can also eliminate this r term right here because you have an r on the other side. Now, this r term actually cancels out completely, but it actually just gets rid of the square value right there. So what we end up with is vt squared equals g m1 over r. If you can see, there is no mass of the satellite anywhere in this equation.